In this video, we're looking at area between functions. It's a bit of a weird topic, but we'll have a look. So we're going to find the area between these functions how we would in methods. So we're going to graph both functions. So x cubed take 6x plus 2. And we'll graph the other function, x squared plus 2. Yeah, there's the functions. We're going to go standard window so we can get a good view at all this. There we go. And we're looking for the total area between them. So maybe I need my x a little bit more condensed and my y max could go out to 15. There we go with that. Yeah, cool. That looks good. So the total area is a really nasty, horrible integral expression. So area, well, it would be the integral from -2 to 0. It's going to be the top function minus the bottom function. So I believe that's x cubed take 6x plus 2 on the top and x squared plus 2 on the bottom. Then it's going to be the integral from 0 up to 3, because I reckon 3 is the other intersection there, of the top function. So that's x squared plus 2 on the top now. Take, and then it's x cubed take 6x plus 2. Okay. So that would be the total area. Now, I reckon that this chapter was put into the curriculum before Casios were invented, because this topic is kind of like trivial on Casios. And you just hit mixed. You hit select on the first one, -2. And then you hit select on the last one, where they intersect, which is 3. And then that little green bit is the total integral, 21.083. Sorry, the total area, 21.083 square units. Done. Okay, so this is how we would sort of do it in methods, and also how we'd sort of do it if we didn't have the Casio to just tell us the area in between. Spec is just a little bit of a weirder version. The area is just the integral across the whole range, -2 to 3, of, yeah, it's the absolute value of, and it actually literally doesn't matter which one you put first. So x cubed take 6x plus 2, take x squared plus 2. Does not matter whether you put the top one or the bottom one, because they flip over. And I'm going to assume that's 21.083, but we'll have a look and see if we can calculate it out. So this one is not really one to do in a graph. It's more of a math run matrix integral, not Python run matrix. So let's see if we can get this integral in the calculator. Math, go across to integral. We're going to go, let's see. I always forget what absolute value is. So what I do is shift catalog, and then I go down to ABS for absolute value. Get some bars there for us. X cubed takes 6x plus 2. X squared plus 2. Okay, the bounds go from -2 to 3, because that's like the whole range we're looking at. And we hit enter. Oh, it's 21.083. Who would have thought? So yeah, kind of unnecessary now that we got Casios, but this would have blown your mind if you were trying to do integrals by hand. It's much easier than doing a whole bunch of crossover points.